So we're here at Surrey Space Centre. My name is Dr. Chris Bridges and I'm one of the academics here at the university. And where we are is we're in our Operations and Control ground station. And what you can see here is all of our screens that we use for actually controlling and monitoring our spacecraft. One of the typical things that we tend to do is we want to be able to command as well as look at all the telemetry that comes down from our spacecraft. So on these screens we usually have multiple viewing platforms available. And some of them may be plotting things. For instance, we look at the altitude here for inflate sail, or we might be looking at raw telemetry, or we might be looking at then the actual RF spectrum itself. And so these are all important indicators that we would use to understanding how a satellite is physically operating when it's actually up in orbit. So the main thing that we use to be able to do that is to be looking at these sort of big racks of equipment. So our satellite equipment here, again, contains lots of very, very key pieces. We start off obviously with our power supplies, but we would then quickly move up to then our rotator controllers. So our rotator controllers are things that then allow us to point in azimuth and elevation, or up and down, northwest, south and east, to be able to then control then where are we physically pointing our antennas. The next part is then the radio system itself, and the radio is then what modulates and demodulates the radio waves that come down from our antennas to be able to then give us then a physical audio wave coming in. This is our baseband audio. After that, that goes through something called a terminal node controller, which then turns these audio waves into their noughts and ones, which we can then put through into our computers to then look and manage then and see physically what is happening. And essentially we do that reversely, going up and down this process, going from the antennas into the radios through the computers to physically see what is happening to our satellites. Now lastly, the next thing that we would typically use in a research institution is software-defined radios. So these are very, very small, typically USB-based receiving devices. And what these do is they essentially will digitize the signal. So instead of us using radios to create an RF signal, what we do is we actually digitize everything using very fast analog to digital converters or digital to analog converters. And I've got a popular couple here. One is the FunCube dongle that's used on a lot of CubeSats and amateur missions, but there's also the RTL dongle which I'm using here for one of our lunar experiments. If we wanted to use something slightly more professional and we actually wanted to transmit with this, we would need to get something a bit bigger, such as a USRP, which can allow us to transmit and receive at the same time. And what this means really is that it's especially important because we can then display everything actually at runtime. So in a typical radio, you actually can't change everything. You would have to desolder things, change component values, to change, for instance, filter sizes. But in software, we can control everything with the noughts and ones that's just inside the computer. This means it can be very, very flexible, we can create things on the fly, and we can view things all at once. So these are all especially important skills to be able to then build up and use and build new RF equipment.